is 1. Okay,
Hmm.
so that's why you have your slope is 1. Now that that's done, so here is the code. Okay, so the code for this is so you have the slope of the weights, which is going to be, oh wait, I haven't talked about that. Okay, so you see how the slope, so for over here, when we are getting when we're getting this part, right?
Yeah.
Right. Okay, so if we're getting this part, then we have this slope, which is x multiplied by that slope. So what it actually is, so this slope actually is x. This slope is actually 2y
Right.
minus y. Okay. So because of that, if we are going to multiply these things together, um, this is going to be a matrix and its shape. So shape is defined by row, column. You guys can't even see that. Okay, so it's defined by row and column. So you're going to have the number of rows is going to be equal to the number of examples you have. Okay. Okay.
Yeah.
And then the number of columns is going to be equal to the number of output features you had, because you need to calculate the slope of every single examples, every single examples output. Okay.
Hmm.
So because you have a matrix, then let's say you have 4 examples and 2 output features, then what you get is a shape of 4, 2. And then for your x, since you have, let's just say you have 3 input features. Well, actually, yeah, so for x is usually going to be equal to the number. So if it's row by column number of examples, and the number of, if you have number of examples and number of input features, okay? So that's what your x is going to look like most of the time, okay?
Hmm.
Okay, so you remember how matrix multiplication says A, B? So a matrix of a shape AB times a matrix of shape BC gives you a matrix of shape AC, right?
Yeah.
Okay, so what we need to do is figure out what they have in common. So for these two matrices, what dimension do they have in common?
Um. I guess I mean, like the fours.
Okay, yeah. So the fours are the number of examples, right? So
Yeah.
that's why what we need to do is, since x by itself would be a matrix of 4, 3. But then here, if this guy is by itself, you have 4 examples and let's say 2 output features. So what you need to do, since b must be the same, the value of b must be the same and they should be in the inside, we need to take a transpose of this. So taking the transpose just means we flip the rows and the columns to get a 3 by 4 matrix, okay?
Yeah.
So using this 3 by 4 matrix, we can successfully multiply the matrices together to get 3, 2. And 3, 2, if you think about it, 3 is the number of uh, input features, okay? And then 2 is the number of output features. And what this gives you is, if you look at a weight, so you remember how, okay, you remember how if you have, let's say 3 input features and then 2 neurons, right? So x1, x2, x3, right? Then you have 2 neurons, right?
Yeah.
So here you're going to have 3 weights. And then you have another 3 weights because each neuron has 3 weights, right?
Mm-hmm.
So you have 3 weights and another 3 weights. So that's in total 6 weights, right? 6
Mm-hmm.
weight values. You look over here with the output of 3 comma 2, that corresponds, so 3, each one has 3 weights, and then for 2 neurons. So that gives you the slope to change slope of W with respect, no, slope of, shoot. So it's gonna give you this, right? It's gonna give you that, right? Oh, you can't even see. Okay, it's gonna give you this, okay? This
Okay.
is what it's gonna give you. So now that we're done with that, right? We get 6 weights, which is how much each weight should change, okay?
Okay.
So now for the bias is much easier because the bias has an x times 1. You remember how over here, over here, so this is 1 and this is x, right? So in total what you're doing is just x. So this, the slope of every point should be x, right?
Mm-hmm.
But then if you think about it, if we have 2 neurons, how many biases do they each have?
1.
1 bias, 1 bias. So in total you have 2 biases. But then if you look at the x, if you look at x, right? For x, it's gonna have a shape of number of examples and number of, what's it called? Output features. Wait, no, not output features. Number of input features, right?
Wait, say that again?
So it's going to be, so the columns are going to be number of examples and then the, okay, so the, what's it called? The row is going to be the number of examples and the column is going to be the number of input features.
Okay.
Okay. So because of that, we need to figure out a way to get 2 biases. Okay. So what we need to
Yeah.
do is, okay, I kind of forgot how to do. Oh shoot. Okay, so I did it wrong. Okay, I talked about this wrong. Okay, so this is not actually x. This is y hat minus 1. 2y hat minus y, right? Okay.
Mm-hmm.
And then we already figured out the shape of this right over here. So the shape of that is going to be number of examples and number of output features, right?
Yeah.
So if you take a look at this, you have 2 neurons, so you have 2 output features, right?
Yeah.
So based on these 2 neurons, we can conclude that there should be 2 output features. And the slope that we get from this graph, right, is
Yeah.
supposed to be 2y hat minus y, which is the same thing as this one over here, the one we did for the weights. So as a result, what we're gonna have to do is take, so the matrix is going to be 4 by 2, okay? Since we already figured that out. So since the matrix is a 4 by 2, and we're supposed to have 2 output features, then what we need to do is we need to somehow get rid of this 4 because it's in the way, right? So what we do is we just sum all of these 4 values together. So each four values, we just sum them together. And then after that, we should get 1 bias and another bias. Okay.
Okay.
Okay, so it's Okay, so the meeting's gonna end in 10 minutes. Okay, so I'm gonna just finish this. Okay, so if you look at the slope over here, it's going to be you just take the dot product over here again, like we talked about. You take the transpose of x, and then d values is the input values from the cost function, okay?
Mm-hmm.
And then the bias values are just gonna be, you just sum them up, okay, along axis 0. Axis 0 is because we need to get rid of the 4, and to get rid of this 4, it's the first axis, but then since Python indexing starts at 0, so that's why we call it axis equals 0, okay?
Yeah.
Okay, so now that we got those, we can start what's it called? We can start training. So what we're gonna do here is, so now that you understand gradient descent, we are going to look at this piece of code. So all this information you should already know. And this is just the data set where if you study for 0 hours, you get a 20% on the test. So continuing along over here, what we're going to do is we're gonna model that backward. So we are going to get the derivatives for the weights and the biases. And then once we get them, we're gonna update parameters. So this is the function to update. We're going to just simply increase by the negative of the derivative, right?
Okay.
That's what you're supposed to do, because you remember this graph over here, where if the slope is positive, see, if the slope is positive, what you want to do is decrease the weight. See, you want to
Oh
negate
yeah. Okay.
the slope. Okay,
Uh-huh.
so negative, you want to increase, so you negate the slope.
Yeah. Yeah.
So over here, what we're gonna do is where is it? Yeah, we're gonna negate the slope over here in the update parameters function. And then we're going to forward again. We're going to get new outputs because the parameters are different. And then we're gonna check our new weight values, and then we're gonna print out our new cost, which is our new error. Okay,
Uh-huh.
so we do it once, and the output becomes, so here's the output. So at the beginning, this is your weight, and then this is your bias. At the end, and then at the beginning, your cost is about 4,000. But then after updating, your weight becomes 612, and your bias becomes 120. And then your cost has increased to this huge number, which is like 8 million or something, right?
Yeah.
So what happened, instead of decreasing the cost, you increase the cost.
Yeah.
And then if
So.
you look at this, the reason is because, so you have 612, right? 612
Mm-hmm.
is your weight. But then based on our data set, what do you think the weight should be based on this data set?
Hmm.
Remember, weight corresponds to like slope.
Just weight of 1.
No, so for every increase in X, how much do you increase in the output?
Oh, that's what you meant. 10.
Yeah, so weight should be 10. We started off with such a small number, and then we increased
Okay.
it way too much, right?
Yeah.
And then what should be the bias? What should the bias be?
20.
20, right? So if you have 20, what happened is we started at 0 and we increased it all the way to 120. That's like 6 times the difference. So that's not very good. So the reason what we need to do is we add on something called a learning rate.